Yeah, yeah. So I have to start now the class. Yeah, the live class. It's about to start just in a minute. Today, I need something very strong for today. So because I'm a little bit tired. So yeah, let me prepare here some. Yes. Yeah. Okay. Okay. You take it. Yeah. Thank you. Thank you. Okay. Hey guys, welcome to a new live class. Having here, I'm ready. I'm prepared with my coffee. It's quite hot. It's nice coffee today. Yeah, and I'm ready to deliver the live class number 20. Hey guys, we already reached the number 20. I am happy to reach that number, and I'm sure we are going to reach 100 more, at least. Okay, so if we have this coffee, so good coffee, then I think that's I'm going to reach 500, 1,000. Nice coffee today. Then, what are we going to do? Well, we are going to go straight to the class, okay? Because we have short time and a lot of work to do. And for all the people that are new here, let me see, people still arriving. So we are going to start with going to the ROS Development Studio. We are going to use the ROS Development Studio. That is a tool that is available online. You should have an account already done. And we are going to use it to do the whole class today. You are going to see how it works. So in case that you don't have an account, please go and create it. And now what we are going to do is to share the documents, the code, and all the information that is related to the class of today using the ROS Development Studio. Okay, so just let me share with you my screen so you can see how I'm sharing with you the code for today's class. Let's go. And here I have, yes. Okay, yeah, so Diego is saying that he would like to have some coffee. That, yes, really recommend you that coffee. It's very good. I don't know what it has today. We'll see. So I will give you the receipt, Diego. But anyway, so here we are at the ROS Development Studio that you can access at rds.theconstructscene.com. Go create your free account and start working with us. But you should have this account previously done to this class, okay? So let's go. Then what I'm going to do is to share my notebook and my code that I have prepared for all of you. And here, by using this share link. So this is the link that you will have to click. I'm going to put this link in the chat of Hangout, of Google Hangouts, okay? So you can click on that link and then automatically my whole project, this project here will appear with everything on it in your ROS Development Studio account. Okay, for that, you need to have the account and have to have logged in into the like this, okay? The chat of Hangouts, it makes something strange. So what I'm going to do first is to shorten the URL. So it's a shorter link, and then we can move to that point. Okay, so I'm pasting the link here. On the chat is there. So all of you can now click on the link and then go and open this ROS Development Live Class number 20. If you open the project by clicking here on the open project, I mean, you don't have to watch now, but I'm just opening the project, okay? Just open it, and then you will get access to that screen. So I'm waiting for a couple of seconds. So everybody has their project already opened. And I can see that her hands is also would like to have to taste this coffee. Yes, definitely. So I'm going to put the receipt for that coffee on the video comments, okay? So you can all prepare one for the next live class and all of us can take coffee, nice coffee. Yeah, great. So then I hope that all of you are getting the code and you are getting inside the ROS Development Studio and inside the live class project. Okay, so you have to open the project. You have first to click on the link on the chat. this will automatically clone and copy all my files of my project into your zone. And then you will have access to the ROS Developers Live class. So I don't see any comment on the chat, so I suppose that everything is working. If you have any problem, just let me know on the chat of Hangouts. And let's go and start, because today it's a little bit long and I don't want to end late today. So let's go to Tools, as always, and let's open the Jupyter notebook. So Diego is confirming that it's working for him. Very good. And then let's open the live class number 20 notebook that is here. So you should get this notebook here. And let's go through it and see what we are going to do today. So just let me tell you that this notebook has been created by Epson and by me by working on this preparing. Diego is also everything working great. So let's go and let's continue. So thank you, Epson, for the hard work that you are doing on helping preparing this. It's a super nice job. And so what are we going to do in this class? Well, basically, along this month, we have been going through the subject of creating Gazebo simulations for ROS. And we have dealt with several aspects. First, we have created a robot model, the URDF model. Then we have added a joint controller system that is a gripper to that robot. Then we have created a whole environment where this robot can move around using SDF format. And finally, on the last class, last week, we have created a plugin for Gazebo. Now, in this class, what we are going to do is how, by using all that of the previous classes, you can create a super amazing, impressive industrial simulation. That's what we are going to do, how to apply all that into a single simulation. And we are going to do some work on that simulation. So as always, if you click here on that cell and press play, you can later replay this class because it will be available on YouTube. Okay, so let's go. What are we going to do on this class? First, we are going to learn about the ARIAC package, which is a full Gazebo plus ROS simulation that has been done by the OSRF. It's amazing simulation, as you're going to see. Then we are going to create some config files for launching properly the simulation. And then we are going to configure some initial states for that simulation. And finally, we are going to create some ROS code that is going to interact with that simulation. So that is all what we are going to do today. So a lot of work. And then what are we going to do? What we are going to use is this package, which is called ARIAC package, created by Open Robotics. And it was created for a competition, an international competition that is called ARIAC in 2017. And now it has finished the 2018 edition, is also available there. And then if you click here, you will get more details about that. And you can get also the source code. You don't need to do that because I have already prepared that source code here for you. If you go to the IDE, and yeah, so that's because I was doing some previous work. Don't worry. So if you go to the IDE, then let me open like this and put it here on the side. Yeah, so here inside the simulation, let me close. Inside here, the simulation workspace, you can see on the source, sorry. Here on the source, you have the ARIAC and have all the code that you can find here. If you clone the code of this kit. Okay, you don't have to do it. We have downloaded, we have compiled it. If you want to have a look, it's there. So don't worry, we provide everything running already. And basically that shows, as in the picture, you can see it's an industrial environment with a conveyor belt, with an arm robot that is taking pieces and put it into some unmanned vehicles here. Those vehicles have to bring the pieces to another place of the industry. Okay, so let's go and let's have a look at this ARIAC package and what it contains. Well, as I already mentioned, the purpose of the ARIAC is to provide test scenarios. So there was competition that was running where the people have to build ROS programs to make those robots collaborate and finish some tasks. That's basically what it provides, this simulation. Well, there were 3 different types of scenarios. This first is when you pick a specific parts and place them on a tray. Or another one is when you are testing that some parts, the robot picks parts, but then they fall down randomly. So you have to be able that to get this, to realize that the parts have dropped, etc. Well, and another one here, it's by assemble, is when you have an order, and then there is another one with higher what's the name, priority, exactly, arrives, and then you have to complete the first one and then leave the other one. I have added here a video that you can select this cell and then press play here, and you can see this video. It's quite interesting because it shows one of the teams how they were doing some of the test, and that's how it looks, the simulation in the environment. That's what we are going to launch in just a minute. As you can see, the arm robot is picking parts, and then it's putting on top of the trays of those manned vehicles, and etc. So different types of parts. There is a conveyor belt. It has to grasp some parts, and well, that depends on the test. Okay, so we can configure everything in a config file, as we are going to see in a few minutes. Okay, so then certain terminologies, yes, that are used in this simulation is that the order. What is an order is a list of parts that they have to be put into a tray of a robot. Then a part, it refers to one element, like for example, in this tray here, you can see that there is a specific part. I don't know, that's a part here, and there is another part there. Then the tray is this blue tray that you can see here, is the tray where you have to put the parts. And then a kit is when you have a set of parts that complete an order. Okay, then what do we have here in the simulation? As I mentioned, we have the conveyor belt, that is this part here. And in the simulation, you cannot see the conveyor belt. I'm going to run it here. You cannot see that the conveyor belt is actually moving, because there is no GIF that is showing the movement, but it's actually producing the movement. As you can see, the parts are moving, even if the image beneath is not showing that movement. Okay, that's more than enough that we need for our simulation. Okay, so then also we have the automated guided vehicles with a tray, and are those vehicles here. They move once you have finished an order. You can send them to be put on at the end of this area. Then it will move to that area, and then you will get some points for finishing the order. And those are the trays where you have to put the parts. And here it's a model of the robot that we are using for that simulation. Is the UR10. And you can see here the names of the different joints. That's important for later, for creating the trajectories that are going to move it. Okay, so let's do one thing first. Let's see the simulation. Let's actually watch it and see how it works. Okay, so for that, let's open it. Here, the shell, and let's launch those commands here. First, we are going to go to the simulation workspace. So let's go to the simulation workspace, and once there, let's do this source install /setup.bash. Okay, so once we have done this, then we can run this command that is going to execute the simulation. So we are going to see this in more detail in a few minutes. But by now, just copy this, the whole thing, okay? You can copy and launch it here. It's a ROS run command, as you probably know how to do it. It's the name of the package and the name of the executable, and then some arguments that we are providing to this Python file. Okay, so here it is starting the simulation, and it's doing a lot of things, spawning the controllers, etc., etc. Okay, so where is our simulation? I want to see my simulation. I want to see where. Very easy. Here, tools, Gazebo. Let's open. And here is loading the simulation. It happens that we get inside some of the bins, but you can get out by moving with the mouse. Okay, so far so good. So here it's the simulation, the whole simulation. Here you can see that there is the UR robot. Here, that one. As you can see, then there are some parts here. Also, there is a camera here. And then we have the conveyor belt and a laser here that is used to detect the pieces. And then we have here more cameras. And here is the unmanned vehicle. Okay, I have to tell you one thing related to the simulation. It's a problem that we have, and it's a very strange problem. We haven't found the error yet, and it's not going to impede that we continue, but just to let you know. And the thing is that those vehicles should have a tray here on this side. And as you can see here, if I move into I'm moving in the notebook, you can see here on this video, let me show you here, around here. Yeah, here, for example. As you can see, here is the vehicle, and then it has a blue tray there. So in our simulation, the tray is not shown, but it's actually there. So that's an error in visualization that we have in the system, and it's going to be corrected in the next days. But at present, we don't have a solution. So don't worry, you can leave stuff here, and it's going to float for this video, but it's okay for this class. Okay, so it's just a visualization problem. Actually, the tray is being visualized here. As you can see here, it's a very strange effect. We don't understand what is happening at present, so we have to debug a little bit more. But it's okay, so it's enough. Okay, so we have here the simulation. I hope that everyone has it. Dodo just arrived. Hello, Dodo. And hope that you can follow. Okay, so let's go. Let's continue on this. So we have launched the simulation and it's running. Okay, then this is a very difficult way of launching the simulation, and we want to provide some config parameters, etc. So let's make a package that allow us to configure this better and launch it better. So for that, let's close. Diego is reporting simulation running. Okay, very good. And hope for the others also. If you have problems, please tell it on the chat, or you have questions, you can interrupt anytime. Then let's close this simulation, Control-C. If you press Control-C here, you can close the simulation. Now let's go and create a package for better launching the examples of our industrial test that we want to build. Okay, so for that, let's create a package. The package has to be created in the source directory. So remember to move in simulations workspace / source. Then here, catkin create package. Let's call it industrial control. And that depends on ROS-Py. Okay, so there it is, it's created. Then if we come here to the IDE and we go to source, let me close here, ARIAC. Now we have this industrial control. And here, let's open the package XML. Package XML opening. The package XML of the industrial control that we just have created, okay? So bear in mind that. I'm going to put it bigger. Then here, beneath, we have to add some build dependencies. And you can just copy and paste those built-in dependencies that you have here. The package that we are going to create depends on the OSRF gear package that is provided by the simulation that we just downloaded, and then some services and messages that we need. So copy this and put it here on the package XML. Actually, any point will do it. So you can put it here, for example, beneath the run the pen if you want. I usually put it here beneath the build, so everything is more organized. Okay, more or less. Yeah. So then save it. And now let's go to the CMake list. The CMake list, we have to do some small arrangements. And let me show here is XML. Oh, I don't remember which type was this one. That it was. I don't remember if it was CMake exactly or makefile. Let me see. Yeah, makefile. Let's put it makefile. It's at least it shows the comments. So what we have to do here is to add, and this part where it says find package, at present is only depending on ROS-PY, but now we are going to add the other packages that we specified on the package XML. So you can copy those here, copy, and then paste here in the find package section beneath the ROS-PY, just like that. I hope that this is clear. I'm going slowly just to not to make to make people follow, but that doesn't confuse you. Then we have to no, that should be already done. They include also. Let me see, should be here. Tracking package include already done. Yes. And then what we have to add is on the install files. So let's look for the install here in the CMake. Here we have the install, and then we have to look at the install files. Here it is, install file. So let's put here this section. You can copy or modify the one that is here directly. Okay, so in order to make it easier, I'm just going to copy. What this is indicating is, hey, please, when you install this package in any place, take into account this config file that we are going to generate in a few minutes. It's not generated yet. And that's it. I remember properly, this doesn't contain anything else. Great. So we got those modifications. Then, now let's go and create. Actually, this is wrong. Yeah, sample gear config. Oh, okay. Yeah. So this is for the configuration of the gear. Yeah, it's for the configuration of the gear. Okay. Okay, so now what we are going to do is to create another configuration file. Okay, so this is the configuration file that we are going to use to indicate to the simulation what are the different parts that we want to put there and what is the type of test that we want to do. So what is specific about this simulation is that the elements that appear here in the area will depend on that configuration file that we are going to generate right now. So it depends on that file, and we'll generate one type of test or another type of test. We'll provide one type of information or another type of information. Okay, so now let's go and create this config file. And let's put it here inside our industrial control. Let's go here and create another folder that is called config. And inside the config, let's create a file that it's called my config.yam. Then you can go here, new file, and indicate my config.yam. Let's open it. So now it's empty. And then inside this file, we are going to copy this code here. Basically, this is a configuration of the simulation. So copy this here, and I'm going to show you what it means, okay? So don't worry, and save it. Well, here it says what is the main use of that configuration file. I just explained to you. It's to indicate the sensors and the position, then the objects that are going to be spawned, and the orders also. Yeah, so if there is an order, which type of order? The orders are still not been added. They are going to be added below. At present, here is the sensors only and the type of robot. So you got here more information on those links. Then what we have here is first, which type of robot arm we are going to use for building the orders. And that case is a Universal Robot 10. And then which sensors we are going to allow to have there. And then, well, we call, this is the name that we are going to call. This is the type. And then this is the pose in X, Y, Z coordinates and also in orientation coordinates. Okay, so you can select different types. For example, brick beam or proximity sensor. And you can spawn several instances of the same thing. For example, logical camera, there are two. One type here and another type here, but the name is different. Okay, one is one logical camera that is around there, and the other one is on the AGV, on the unmanned vehicle. And then there is a laser also. Okay, so basically that's it for the configuration. Then let's have a look at the things that we have done through the past live classes. And let's see how they have been applied here, okay, before we continue creating the simulation. So one of the things that we can see here is the wall. So let me move up, okay? Let me move up. So here, as you can see, we have the robots that are here, one robot here, another robot here. Then we have the whole environment. And as you remember, there was a class where we defined SDF wall files that describe the whole wall. So that's also included here in this code. And it's included in one file that is called gear wall template that you can find here inside the ARIAC package, OSRF, and here walls. If you open that file, you're going to see that it follows more or less the same structure that we have indicated in the class, in the live class. SDF, name of the wall, then a camera, okay. Then we have indicated, for example, include the sun, and then, okay, that's more lights. Then include a model. If you remember, we included models. Here, it includes another model, but with some stuff in the middle of there. Okay, so the guys who have built this simulation, they are pro. I mean, they are very, very good. And what they have done is to create a kind of script template for building the model, the wall, using this template wall. Then what this means is that all those models that are inside those tags, they are going to be spawned or not, depending on the configuration file that we have here. And then it could happen that some of the models are going to be spawned several times. Yeah, because we have indicated here, for example, the logical camera several times, or any other things that you will see later. But basically, what it's containing this SDF wall template is exactly the same as we have seen on the previous class, a little bit more advanced, but that's it. So that's just to show you that a wall file is being used in this example. Then another thing that is being used is for example, well, the models. Actually, the models. We have here a folder that contains several models that have been built in the same way as we built the ones on the previous live class. And here you can see it has the meshes, it has the config, it has the SDF. And if you open, then you will see here the description of the model with everything, with the different parts of collisions and also the meshes. At some point in time, the visual should appear here. Yeah, here it is, the visual, and it's indicating the die file. So this is the same as you have seen, okay? So nothing to be scared of that simulation, because it's using at a strong level, but it's using what you have already learned. Then what else do we have here that we have learned on previous live classes? Well, we have the UR10 arm, and then the controller that controls that arm. As you can see on that directory, ARIAC, let's see, OSRF gear, then launch, yes, and UR10, and then the control file is here. Okay, the location is not the one that I explained to you. It has to be inside the config. I would have put here inside the config, but it's okay. So it's not mandatory. What they mentioned, the way I mentioned to you, I taught you is the, let's say, the academic one. So these guys are pros, so they can do whatever they want. But it's the same principle. It works the same way. And here you can see the arm, the type of controller, and the joints that is controlling. So this is something that I didn't explain to you, but you can use a controller to control several joints. So you don't have to specify the same type of controller for all the joints. Basically, it's the same principle. It works the same, but you just to specify the list. And then here, you also specify the PID values for each one of them. Okay, so again, it's the same thing that you have learned, but a little bit more advanced. And then also I would like to show you the URDF model, okay? Because yeah, you need to see that what you have learned is already, it's also applied here. And it's not here, is the URDF model is, let me see where it is. I don't remember where it is actually. It was, I see that I haven't written here. So let me just have a look, quick look. If I don't find it, then it should, maybe it should be here in models. No, where I am, in launch, not launch. And let me see. No, okay. Work cell. Well, I don't remember now where is the UR model. Here in vendors, okay, here in vendors, okay. So here you have the UR description and the UR gazebo, as I explained you in the class. And here inside the UR description, you have the meshes and the URDF code. And okay, you can open here and you will see that is describing the links with the visuals and the collisions as we saw on the previous courses, okay? So with those knowledge, you are able to build a simulation like this one, so complex. Okay, just to review that what you have been learning in the past weeks, it's applicable and it works. So I'm going to close all this except my config yam. And then let's create a launch file to launch our simulation without having to type that strange thing. So for that, let's go to here to our package. Let me close this because too many things. And here in industrial control, let's create a launch. New folder, launch directory. And inside this launch file, this launch directory, let's create a new file. Let's call it simulate.launch. Okay, and let's open it and copy the code that is here. So I'm going to show you, okay, what it means. First copy, paste, and then let's have a look and select that is an XML. Okay, so what do we have here? What we have is a typical launch file. You already know how this works. First, there is a name. Okay, this is a name, whatever we want, config file, it's okay. Then it says, hey, please. Okay, no, sorry, no, this is the ARC. Sorry, I was thinking of the node. This is the ARC. So what is loading is this, in this parameter, all the configuration that is on that myconfig yum file, okay, that we are creating here yet. So it still is there. Okay, this is one thing first. And then the second is to launch the node. This is to launch what we have launched previously here on the top, that we have launched using this strange command here so long. So we are going to put it inside here in a normal way of launching it, an academic way of launching. So this is the package. This is the Python file that we want to launch. This is the name, it's just whatever we want to call it. Output of this on the screen, of course, and then the arguments. These are the arguments that we are providing, okay? And this, what it does, as you can see, this is the same parameter that we have here. And then the F, it's indicating, please, as an F, take the argument of the config file. That the argument is the variable that we have defined previously here. Okay, and what value is all this path. It's all this path. So the config file, as you can see, is this name. It's going to be substituted by all this. That is our config file that we have defined here. Okay, you can save it, and then let's go continue. So, yes. So you can save it, and then it's ready. So actually, here we should compile the package in case that we have any messages or anything. So yeah, let's do it. Okay, so let's do that step. So for that, in order to compile your packages, you have to go one directory up. So you have to be on the simulations workspace, and then type the command of catkin make ---- pkg, and this is just to tell the system that doesn't just compiles our package, because we don't want the system to compile everything that is there. Otherwise, it will take a long time. And it will compile all the other packages that we have already installed for you that comprise the whole simulation here, the OSRF gear simulation. Okay, so here is configuring and doing whatever, and then finally it's compiling. It's not yet configuring yet. Okay, and that's it. Then now let's try that this can launch our simulation. So for that, we need to source again the install. So let's source it. Install setup.bash. Actually, that's not necessary, but anyway, let's copy this. So then let's launch our package. Sorry, let's launch our package. How do we do? ROS launch. What's the name of our package? Industrial control. Industrial control. As you can see, it's not recognizing our package yet because I'm doing double tap and it's not autocomplete. This is sometimes happens in ROS. When this happens, you can do a ROS pack profile in order to recognize any other new package that has been created or installed. And then now we should be able to autocomplete. Industrial control simulate launch. It autocompletes everything. Okay, so let's, sorry, I pressed one wrong key. There it goes. And there it goes, and then it should appear everything in our simulation window. Okay, this is not yet. This is the previous one, as you can see, waiting for WebSocket. This is now, it's reloading our simulation. Okay, so I got it. So what do we have now different from the previous one? Okay, so that should be your question. So what we have now is first that we have a launch command to launch everything. But more than that is that we have a launch file that is launching the simulation, taking into account a config file. Okay, so now let's modify this config file in order to allow us to do a test, one of the official tests, well, more or less, official tests of the competition, okay? So you should get something like this in your screen. Then what we are going to do is to add those parts for configuring the orders and the belts in the simulation. So we had to put all this information on that config file. And basically what it says is how the orders are going to be generated and in which parts are going to be generated, whether we are going to put some parts on the conveyor belt, and then also if we are going to fill the bins with some parts, and which parts and which location. So actually we don't have time now to execute everything, so to go in detail, but basically this, you can see the details of the description here, and also if you need more information, you can check this link here that contains all the configuration parameters. And so what we are going to do is to copy this configuration. Let's copy here up to the point that it says ARM, because we already have this part. So copy this to this point, and then come here and put it on top of the file. Okay, so what basically we are doing is how to configure which orders we are going to do. One of the orders is going to be about piston rod parts, and the other one is about the gears parts. Okay, so that's two different orders, and one of the orders is going to be completed by the belt parts. So in the belt, we are going to put the gears, and on the bins, we are going to put the pistons rod parts. Okay, so just check about this in detail on the extra information. But now let's save this. Whoops. Let's save this config file, and let's continue now. So yeah, so now if I remember properly, well, first, so let's have a look here at the robot that we have here. So we have this robot that is the UR10. Okay, that's a robot that is going to do the completion of all the parts. And what we are going to do, this robot can move because it has a controllers activated. And you can send to that controller, you can send trajectories. And so how do we send trajectories? By writing into the joint trajectory topic. We learn about this on the controlling class when we were doing a controller for our arm. So we learn about that. Okay. So what we are going to do now, let me open a new shell here. Let's open a new shell and let's do a ROS topic list. And we should have here for the joints, we should have this ARIAC arm command trajectory message. ARIAC arm trajectory, where is command trajectory? Okay, so it's not appearing here. Let me see what is the problem. So I cannot see here, the topic is not there. So could it be that there is an error in the, no, it says the joint state controller is being correct. Okay, let me see, I don't see the error now. Any suggestion from the people on the chat? I cannot see it, the error. Any suggestion? So, no, okay. Yeah. Okay, wait. Okay, is that one? Is the ARIAC, Epson is suggesting ARIAC ARM command. Let me see if it is this one. Let me check that. Cross topic info, and here. Okay, yeah, that one is accepting that, but I don't understand why it's having that topic instead of this one. It could be an error here. Oh, sorry, no, it's my mistake. It's my mistake. Yeah, so I wasn't reading properly because I was okay. So it's my mistake in reading here. Yes, of course, is the ARIAC ARM command topic, of course, and that's the type of the message. Yeah, that's correct. Okay, sorry, my mistake in reading on the screen. Then let's go. Then what we can do is, because this ARM command topic is the one that is accepting trajectories for all the joints of the UR5, what we can do is to, for example, in order to test it, is to publish one trajectory to that joint. So let's do it by copying this command, the full command here. Okay, this is just an example. Then afterwards, we are not going to use the public topic. This is just a way of showing how it works. Then put on one side your screen the robot, so you can see that the robot moves. And then on the other side, paste the command that contains a trajectory for all the joints of the robot. And then, as you can see, the robot should be moved. Oh, yes, Diego says I should get some more coffee. Yes, you are right, coffee. Thanks. Thank you. That was the reason. Yeah. Okay, great. So now it's moving the robot there. We got it. So basically what we are going to do is to control the robot, that robot, by applying several trajectories in order to accomplish the whole mission, the whole goal of the robot. And what is the goal? Well, is to accomplish the orders that we have defined here. One is the order number 1, number 2, and here is the order number 1, sorry. Okay, so let's go and let's launch everything so that the robot can see the proper scenario for accomplishing the orders. Okay, so that simulation that we have here, remember, is not running this config file. So now what we are going to do is to close this, close the simulation, Control C, select here, and then press Control C. Control C, yeah, sometimes it takes some time to close. That's normal in Gazebo simulations, no problem. And now we just can relaunch it because it will show the whole simulation with our configuration, okay? So let's launch it again. And then it should appear now with a different configuration. You're going to see that there are some parts here, and also that there are going to be spawn some material, some parts on the conveyor belt, for example. Let's see, it's opening here. Again, this position inside. Yeah. Okay, so here we are, and here we are starting to get those parts that are the ones that we are going to use to put into the vehicle here by using the ARM robot. Okay, so then we don't have a lot of time for executing this, but we have included here a code that is solving the task, actually. So this is solving the task that we want. It is to grasp 2 parts from these, it's going to grasp 2 parts from here, from the bins, and then put it here on top of the vehicle, and then grasp 2 other parts from the conveyor belt that they are going to start to appear, and then put them also here. Then send the vehicle for revision. Then the robot for revision, it has to move up to this part here at the end of the fabric of the whole environment. So that's what this code is doing. And unfortunately, we don't have time to watch it in detail, but you can watch it. Also, there is a small description here about the different parts. And then what we are going to do is to launch it and see how it works. So for that, we have to go back to our package that is called industrial control. And let's create here a scripts directory. Create a new folder and do scripts. Okay, and here you create a file that is called, let's call it tasker.py. Then it says new file, tasker.py. Okay, and here inside, open that file and copy the whole cell content. You can select the cell and then do Control A to select everything, and then Control C to copy. Come here and do the paste. Then save it, save this. So we have that tasker that is going to solve that problem there, the whole problem. We are going to see in a minute. Then Diego is indicating that my RDS started to act very laggy. Okay, so I can do nothing about that now. It may depend on many things. It could be your internet connection that is working strange. And anything else, I cannot see any reason, because you have, every one of you, you have a direct connection to a dedicated computer. So it's individual computer. It doesn't depend on how many people is doing this class. So I don't know what could it be. Maybe we can discuss afterwards. So let's go and launch this code. Okay, so I presume that all of you have created this tasker.py inside the scripts directory. Okay, then one thing that we have to check is that this script contains the permissions for execution. So you have to be able to do that, because otherwise it's not going to work. Then for that, you can check, you can use this command, chmod +x. So you have to go to the directory. You can go like ROS cd industrial control /scripts. And then here, you have to do an LL. It will show us the permissions. It doesn't have the execution, the X permissions here. So you have to add it. How? chmod +x stalker. Tasker, sorry. Tasker.py. And then we do an LL, and we can see that now it's also in green, and then it has the X permissions here. Great. And now we can launch it. So we don't have to do this launch now, because we have already done it in the previous shell. So the simulation is running. And now the only thing that we need to do is to do a ROS run mytasker.py. So we are going to actually run this script. ROS run my task. Many things on the desk. Sorry, tasker.py. My task. No, sorry. This is not correct. This is not my task. It has to be industrial control. Sorry. Because we have put it inside the industrial control. So it's ROS run industrial control, then tasker.py. Exactly. So there it is. So there it goes. Just switch to the Gazebo thing, and then you can see that the robot is starting to move. It has grasped one part, and then it's putting the part in there. As I mentioned to you, the tray is not visible, but the collision is properly set, so it's showing there. You can see that the robot is moving to another element. It's grasping it by using it's a system that it's compressed air, kind of compressed air, and that's what it's doing. Okay, so it's grasping all the parts, and now what it's doing is going to the conveyor belt and trying to capture the parts that are coming here from the conveyor belt. And when this piece is detected by the laser, then the robot knows that it's moment to go and grasp the part, as you can see. It grasps, yes. And then it's moving here and putting on the tray. Okay, and then it goes to the other part that is here, and it's going to grasp it also when it's detected by the laser. And now it's grasping and this. You can have a look at the code, how all this is implemented. And that is quite amazing code because it's done taking into account everything of the robot. Then now it has finished the order, and now the robot, this robot containing the pieces is going to be sent for revision. So you can see all the messages that the parts that are being submitted, and it's in red, but don't worry, this is not an error. It's just that the message selected for showing that is the error message. It's an error in notification, but not actual error in the simulation. So basically, that is the point. That is the point. I have put here some other courses that are related to what you have been learning here, like the ROS Industrial course that we have in the Robot Ignite Academy. Remember, it's a Robot Ignite Academy. It's an academy that teaches you about ROS online and using simulations and the same procedure as you are seeing here, but you can do it by your own. So you can see the notebooks, the simulations, the compilation, the creation of the packages, everything. And we have many, many subjects. Have a look at the robotigniteacademy.com. And here I put some courses that are related, the ROS Industrial, manipulation, and even the ROS Basics, in order to understand what is all that about topics, etc. I have included here a coupon that will provide you with a 5% discount until the next June, of course, after the next class. It's a valid only. Okay, so basically that's all for today. Just, yeah, Diego is indicating that it's working for him, and I'm so happy, Diego, that you managed to do that. Very good, super. And what about the others? If you have any question, I'm here for a couple of minutes more. And just let you know that we are organizing an online conference next month in July, actually, 7th, 8th of July, that where a lot of experts are going to come and give a class like this one online on different aspects. And so you can attend, you can enroll this at ROS DevCon. You can enroll at that conference and learn a lot from those experts. So that's it, basically. So if you have any question, let me stop sharing the screen. And here, I'm here for you for answering your questions while I'm having a little more of coffee. I don't know where is my, oh yeah, so she brought it. So, well, still a little bit of coffee. Let me know, do you have any question? If you don't have any question, let me explain you while you think about the question. It's about the courses that we are going to do on the next month. In the month of June, we are going to dedicate the whole month of using OpenAI to train robots. OpenAI plus ROS. So we are going to do one live class every Tuesday at the same time, and it's going to be about a subject related to using OpenAI to train our robots. So you're going to learn a lot about how to use artificial intelligence to make the robots do some things. So we don't have to program because it's a lot of work to program. It's better if they are able to learn. That is why we are going to use some reinforcement learning algorithms, maybe deep learning also, etc. And here I have a question from Juliana. Oh, no, sorry, it says just hello. Hello, Juliana. Nice to meet you. And that's it. If you have any question additional that you can think later, you can post it beneath the comments of the video. Or if you have a suggestion, for example, for another class that you would like to have, hey, I would like to have a class about this, about that. For example, somebody suggested us to have a class about FlexB. FlexB is an environment that allows us to build powerful state machines for creating behaviors of the robots inside the state machine. So that's very good. So finally, Juliana is saying gracias. Okay, gracias to you, Juliana. It's a pleasure. So let us know about this, your suggestions, questions there on the comments, and see you next week, okay? That's all for today, guys. Keep pushing your ROS learning. Bye-bye.